Welcome. The Word of God in Philippians 4:19 says, "But my God shall supply all your need according to his riches and glory by Christ Jesus." What a wonderful word it is. Today we're going to be looking at measurements from the Math June 2017 past paper. We're going to be focusing on the solutions for questions 32 all the way through to question 40. I'm Teacher Walton, and this is brought to you courtesy the Math Ministry. So in question number 32, it asks us, how many kilograms are there in 1 ton? And we know the answer to that is 1,000. So question 32, answer C, 1,000 kilogram equals 1 ton. Question 33. Question 33 wants to know the volume of a cube of edge 3 centimeter. The formula for volume is length by breadth or width by height. And if we are looking at a cube, it means that all of those 3 sides will be the same, and in this case it's 3 centimeters. So your answer for number 33 would be 27 centimeter cube. Again, that will be answer C. Now move on to question number 34. Question 34 wants to know what is the speed of a car, and that question gives us the important information. So question number 34 wants to know the speed of a car, and we are told that it travels 80 kilometers. So the distance is 80 kilometers, and the time taken to cover that distance is 2.5 hours. So let's write that as 5 over 4 hours. 5 over 2. Let's take that out. 5 divided by 2. Hours. Now, the formula for speed is distance divided by time. So we are given a distance of 8 kilometers, and we are dividing by our time, 5 divided by 2. So let's see how we work that out. I'm going to change the division sign to this, divided by 5 over 2. So this works out to be 8 over 1 multiplied by 2 over 5. So this will give me 16 over 5. Let's see what the answer reads here. Okay, so in this question, my 8 is supposed to be 80 kilometers, not 8, 80. Let's fix that. So that'll be 160. Right, it's stated here, 80 kilometers. Right, so 5 into 16, 3 5s are 15. 5 into 10, 2. So the answer should be 32 kilometers per hour. Right, so in this one, it's answer B. 32 kilometers per hour. So let's go to number 35. Question 35 gives us a figure in the form of a triangle and a square. So we have something looking like this, triangle here, and you have a square below. You are told that the side of the square is 5 centimeter, and the perpendicular height goes up all the way here, that is 4 centimeters. and we are asked to calculate the total area of this figure. Well, let's start with the two basic shapes. So we need to find the area of the square, and since the side of the square is 5 centimeter, the area of the square is side by side, which will be 5 by 5, giving us an answer of 25 centimeters square. The other basic shape we are seeing there is that of a triangle, so we need to find the area of a triangle, and the area of a triangle is the half multiplied by base multiplied by a perpendicular height. The base is 5 centimeters and the perpendicular height is 4. So this will give us half of 4 is 10 centimeters square. So we can see here now that the total area will be 25 plus 10. That answer. And 36 is understanding of areas, but in a slightly different way. Let's see what it says. So you're given a rectangle, the area of a rectangle. So let's draw a rectangle here. We are given the area of this rectangle, and this area is 53.6 square centimeters. Right, so something happens to this triangle. Not triangle, sorry, something happens to this rectangle. The length is multiplied by 4 and the width is half. So if this is our length L and here we represent our width by W, we have a new triangle where the length is multiplied by 4, so therefore it's much longer, and now the actual width is reduced, it's half. So our new length here would be 4L, the length is multiplied by 4, and the width is half, so it will be half W. So we need to find the area of this new rectangle. What is the area of this new rectangle? Now that's all the information they give us, so we need to make a comparison between rectangle number 1 and rectangle number 2, the area of those two. So let us first write down some information concerning rectangle number 1. So the area we know here, area is length by width, LW for short, and we know this area is 53.6. Now let us work out the new area of rectangle 2 after the adjustments. So area here, let's call it area of rectangle 2, will be length, which is 4W, multiply by our width, which is half W. Okay, let me correct that. The length is L. So if the length is multiplied by 4, this should be written as 4 times L. So it's 4L multiplied by half W, length by width. Okay, so let's simplify. Half multiplied by 4 is 2. So this becomes 2LW. So the area of rectangle 2 is 2LW. Now, we have information about what LW is. LW is right here. That's the area of rectangle 1. And we know LW has a value of 53.6. So we can now replace that information across here. So area of rectangle 2 is really 2 times the area of rectangle, rectangle 1. And we have a value for the area of rectangle 1, which is 53.6. So that will enable us to work out the area of rectangle 2. So 2 multiplied by 53.6, 6 2s are 12, 3 2s are 6, 7, 2 5s are 10. That's 107.2 centimeters square. So let's search for an answer that says that. That is answer C. Okay, let's move on to, all right, let's correct that. That was question number, that was question number 36. 36. Question number 36. Let's move on now to question number 37. So this question is testing our understanding of the 24-hour clock. So it tells us that a man leaves home at 22:15 hours. So he leaves his home at 22:15 and he reaches his destination 4 hours on the following day in the same time zone. So we know it takes him 4 hours to reach his destination. Right? So his destination, whatever that building is, he reaches his destination 4 hours later. So the question is, what time did he arrive there? Or how many hours did the journey take? Okay, so let me recap that. Let me read the question again. A man leaves his home at 22:15 and he reaches his destination at 0400. Right, so we need to remove this information. That is what we need to find. How long did his journey take? Right, so let's recap what this 24-hour clock is about. So if you have your 24-hour clock, the first half of the day moves from 0000 hours, that is 12 midnight, and it goes up to, first half of the day, it goes up to 12 noon. And then the second half of the day, which is afternoon, let's use a different color for that one. The second half of the day, afternoon, starts from 12 noon and we keep adding 1 to 12 and let's see where we are. So if we are at 22:15, that's when he leaves his destination, his home. If we are 22:15, it means that, let's see what time that is really in reality. 22:15 minus 12 noon, that gives us 10:15. So he leaves his home at 10:15 in the evening. And it says he reaches his destination at 0400. Now going back to the first clock here and read 0400 will really be right here, 0400, and that is really 4 a.m. in the morning. That's equivalent to 4 a.m. So let's put that information on So on another clock. So he leaves at 10:15 p.m. and he reaches his destination at 4, let's say 4 o'clock in the morning. How long? So it'll take him to reach here midnight. It'll take him 1 hour and 45 minutes, which is 1 3/4 hours till midnight. And then he travels again for additional 4 hours, which will take him until 4 a.m. So the total time for his journey will be 5 hours, 45 minutes, or 5 3/4 hours. And that will correspond to answer B. Okay, let's go to question 38. Question 38. Right, question 38 talks about the distance around a lake is 8 kilometers on a map. Distance around a lake is 8 kilometers. Right. Right, I'm just drawing it circular. It could be any shape really. Distance around a lake is 8 kilometers. On a map, this distance around the lake is represented by a length of 2 centimeters. So you have on a map now, okay, so let's say the second diagram to represent our map. And you may have a little speck on this map representing your lake here. And on this map, it is 2 centimeters. So you're talking now about how you interpret scale drawing. Now you need to bring your measurements to the same dimension. So you cannot compare kilometers with centimeters. What you need to do is to convert, to determine your scale, you need to convert your kilometers to centimeters. And let's see how we do that. So 8 kilometers, let's first convert that to meters. 8 kilometers is 8 by 1000, which is 8,000 meters. And we know that 1 meter is 100 centimeter. 1 meter equals 100 centimeters. So we need to find out 8,000 meters. So 8,000 meters will equal 100 by 8,000. Let's see how many zeros that'll give us. 2, 1, 3, 5 zeros. So that will be 8, 1, 2, 3, 4, 5 zeros. So 8 kilometers is equivalent to 800,000 centimeters. So now we are in a position to determine our scale. So that corresponds to 20 centimeters on the map. 20 centimeters corresponds to 800,000 centimeters or 8 kilometers, which is the actual distance of the lake. And now we can just simply simplify that. Divide both sides, let's say by 20. So that will give us a scale of 1 centimeter. Let's work out that now, 20. 2 into 8, 4. 4, and we are now writing 1, 2, 3, 4 zeros. So our scale is 1 centimeter to 40,000 in this case. Now that's if you work it using the wrong measurements. They didn't ask me what was, I compared 20 centimeter here. So the scale wasn't 20 centimeter. They say in the drawing, the scale was what? 2 centimeters. So let's rework this part using the correct information, right? So this is incorrect. Let's do it here. 2 centimeters corresponds to 800,000 centimeters. So let's again simplify this. So if we divide by 2, let's see what the scale would be, right? Okay, let's just divide by 2. If we divide by 2, this comes down to the correct scale now, which is 1 centimeter to 400,000, right? That's the scale we're using here, right? Of course, we can take out our cm. So your answer here will now be D. Okay, let's proceed to the next problem. In question 39. 39, you're given the perimeter of a square. This is your traditional problem, and they want to find what is the area. What's the area of the square? So in number 39, let's go. So you have your square, and you're given the area of the square. The area of the square, no, in fact, they give us the perimeter of the square. The distance around the square is 56 perimeter. And we need to find out what is the area. Now, the square has 4 sides, as we know. 1, 2, 3, 4. 4 of these sides. And if they are all of the same length, because it's a square. So the perimeter corresponds really to a length of 4L, and this is your 56 centimeters stated. So one side of the square represented by L will be 56 divided by 4, which is 14 centimeters. Now, another formula that we need to remember is the formula for the area of the square, which you know as what? Side by side? That's correct, side by side. So, if we need to find the area of the square, L is what we're using as our side. So, it will be L by L, 14 by 14. And let's see if we get this multiplication correct. My guess, it should be 196. Let's work it out. 1, 4 by 1, 4. 1, 4 is 4. 1, 1's a 1, 0. 4, 4's are 16. 4, 1's a 4, and 1 is 5. 196. Right, now remember to put in the correct dimensions here. The length is 14 centimeter each, so your area must be centimeters square. Okay, so that'll correspond to answer D. All right, so let's change color as we move on to question number 40. 40 is talking about the volume of a cylinder. They give us the radius and the height. So let's see if we can get that drawn here. That's your cylinder, looking all nice like mine. And we're told the height of this cylinder is 8 centimeters. Right. And the radius here, the radius is 3 centimeters. Now, if we need to find the volume of a cylinder, let's start from scratch. So if we're not relying on any formula, although your formula will be given, volume of a cylinder is your base area by your height. Now your base area will be the area of that circle, and I've shaded it here. Your base area will be in the form of a circle, and the area of a circle is 2 pi r. And we know height is always h, as shown on the diagram right here. Height is always represented by h. So the volume of a cylinder is really 2 pi r h, and let's call that v. So this is the formula we need to use in your problem. So let's work it out. So 2 pi is also a constant, so it's 2 pi. The radius we are told is 3, so you multiply by 3, and the height is 8. So let's simplify. 2 3s are 6, 8s are 48. So that will be 48 pi. And of course, your dimensions of volume is always cubic. In this case, it's cubic centimeters. So it will be 48 pi centimeters cube. And that gives us an answer B. And that was your question number 40. So that will conclude our questions for the 2017 June CSEC paper 1 on measurement.